Hey there and welcome to Build It. As you've probably guessed already, in this project we're going to be building the lighting system for a skateboard. So I really don't skate that often. I used to skate to work every day, but that isn't really possible with my new job, so I had to kind of forget about it. Until recently when I saw a lot of people doing these night rides on bikes and skateboards, and I thought I really want to join that with something flashy. Yeah, and that's pretty much why I built it, and to be perfectly honest, I'm really happy with the outcome. So to build it, we need a typical microcontroller, in my case I'm using the Arduino, a battery manager, L-wire, and the all-important NeoPixel. Now, you don't have to use a NeoPixel, but it will make your life just a little bit easier. Here, check this out. If we were to use 8 standard RGB LEDs instead of the NeoPixel board, the wiring would increase by 10 times. Instead of soldering 3 wires, we would have to solder 30. So each RGB LED has 4 legs, 1 for ground and 3 for the 3 main colors, red, green, and blue. Each one of these 3 colors needs to be controlled by a pin on your microcontroller. This isn't too bad if you have 1 or 2, but when we have 8 RGB LEDs, we would no longer be able to use the Arduino Nano or Uno. We would actually have to use the Mega because we would need so many pins, which would just make it huge, overkill, and just too expensive. Using these addressable LEDs makes the wiring so much neater, but this also brings the downside of having to learn how to control them through code. If you've been subbed to this channel for long, you'll know that we just uploaded the video on how to control these, so if you're interested in that, check that out. We'll cover the basics in this video, but for some more details, check out the other one. So the first thing to do is kind of plan out how we want this project to look. For example, my board has a pink kind of vibe to it, so I want my lights to reflect that, which we can set through code. Everything else also has to be really strong, as I don't want this thing falling apart during use. And lastly, I want to have some kind of cool animations, so if I choose to use this as a display piece, I'll keep the person looking at it interested. I also did think about adding more features like Bluetooth or Wi-Fi, but the more I thought about it, the more I wanted this to be a kind of hands-off, just turn it on and go kind of project. I really wanted to avoid pointless setup every time I wanted to use it. For example, the Bluetooth features I added to the Arduino Smart Blinds project are hardly ever used, and whenever I do use them, it's kind of like, okay, hold on, let me turn on Bluetooth, now I'll get the app open, oh it crashed, give me a sec to restart my phone, instead of just pushing the button that's right there. Anyway, we can start off with the main code now. I'm using the Arduino IDE and the Adafruit NeoPixel library, and I'm pretty much just using the original NeoPixel example as a guide. I'll create a function for some animation, in this case it's the LEDs turning on in the forward motion, and then I'll reference that function in the main void loop. This makes the main loop really neat and also makes it really easy to repeat functions, which I ended up doing a lot. You can find the fully commented code in the video description if you want to learn more about what's going on, or you can check out the last video. Now with the code done, we can put our sketch onto the Arduino for testing. This makes it much easier to tweak small things about the code, like the delays and the colors. So in my sketch I've got 10 animations, which are left, right, fade forward, fade 0, fade 1, fade 2, fade 3, flash, chase, and chase back. Once you're happy with how everything looks, we can move on to creating a case for it. I actually went and got a whole new 3D printer just to print this project, so I can sadly retire that rough 3D printer from the Pimp My Printer video. Anyway, we're going to be printing 3 parts: the base of the main piece, the top of the main piece, and a smaller piece to be used as a riser. Links to all these parts, as always, can be found in the video description. It took about 5 hours to print and came out really nicely in the end. I used the Zen pink filament, which really matches the colors of the project quite well, but I also ended up printing it in brown as well, just to see what it looked like, and it actually looks great on other skateboards, so choosing the color that suits your skateboard is really important here. Now with the piece printed, we can start assembling the final project. Of course I want this to be battery powered, so we're going to need space for the battery and the actual circuit that covers recharging and discharging the battery. Then we need space for the main controller, and finally space for the switch. It ends up being a pretty tight fit, but you could fix this if you wanted to by using a smaller battery. I just chose to use a larger 18650 because it's got a pretty high milliamp hour rating, which means it should last quite a while in between charges. Now obviously the Arduino Uno doesn't fit in here, so I ended up using the Arduino Pro Mini instead, and I used the Arduino Uno to program it. Now something I didn't realize is you can actually use the Arduino Uno to program the Pro Mini. If you look at the Pro Mini, you'll realize that there's no USB chip on it, so you can't just plug it into a computer and upload code like you would normally. However, if you remove the processor on the Uno and plug the Pro Mini into it, you can actually use the Uno as an uploader. I'll leave a link in the description of a tutorial on how to do that if you guys are interested in that. Once this is done, everything can be soldered together. The NeoPixel source pin gets connected to pin 6, ground goes to ground, and then VCC goes to 5 volts. Now make sure to use some long wires, because these wires are going to be tucked into the groove to power the NeoPixel, which is going to be glued in front. My battery balancer is outputting a nice 5 volts, so I can wire that directly to the 5 volt pin of my Arduino, and lastly the battery can get connected to the inputs of the battery charger. Now on the actual casing you'll see these little slots here. These are where we're going to super glue a nut in place so that we can connect the top piece to the bottom piece together with a screw. Glue the nut in place and then screw the screw into it. With that done, you should feel a pretty tough case ready to go. Next we need to start doing some work on the board. We need to take the trucks off and then put these in place. Now these pretty much screw in the exact same way you'd screw in a normal riser. Just put the screws through and then put the trucks on top and you're ready to go. Pretty straightforward. With that done, we've got a pretty awesome skateboard with some underlines that cause some really cool effects. The NeoPixels are really bright, so they work during the day, but of course this looks better at night. I was kind of tempted to leave this project as it is, but then I found some L wire in my workshop that I had left over from another project. It was the perfect color for this project, so I just had to install it. And that's pretty much as easy as soldering the L wire to the AC adapter and then gluing it on the edge of the board with some really strong super glue. Now this isn't quite as strong as the other mod. For one, if you bump it and break the L wire, it won't light up anymore. Also the converter's kind of just glued in place. Now we could go back and print another one of these and put the circuit inside of it, but for this version I think it's more than enough. And that's it. I'll be posting some more videos and updates of it riding around in town on Instagram and Twitter, so if you want to follow me, check out the link in the video description. As always, there is a full written instruction in the video description as well. Also, please leave some project ideas in the comments. I'd love to see what you guys want me to make. Thanks so much for watching.
Yeah, we're good.